All right, now we're calculating the vertex, and we're going to go through both equations for the vertex in one video. So we're just going to find it right away. We have our CA, we have our L1. Those are the only two we need for the moment. So cosine of LV is equal to cosine of 51.39 times the sine of 156.7. So we come here, cosine of x times sine of t, cosine inverse $75. Wow, okay. That threw me off because it was such a high number. But remember, we're working with such a steep curve here that the, I wish I still had the apple, but I ate it. The vertex, which is normally, you know, in the previous problem, not that hot far up to the north because we were only going from like 20 to 30. So we only ever reached 34. But here we're going on such a steep angle that it's going to come all the way up to 75 degrees south and conversely 75 degrees north. But we're only working in the southern, we're only worried about the southern vertex here, not the northern vertex. So the latitude of the vertex is equal to 75.7 degrees. We have to break that up. So I'll write to the side here, 75 degrees do, well, first we'll store this as A. So LV is 75.7 degrees, which is equal to A. And then we're going to do minus 75 times 60, 75 degrees, 43.2 minutes south. That's our the latitude of our vertex. Now we're going to find the DLO of our vertex to find the longitude of the vertex. So sine of DLOV is equal to the cosine of, always forget that, CA, which is 156.7 degrees, divided by the sine of LV, which is 75.7. So we're going to do cosine of T divided by sine of now A. We're going to do sine inverse of answer. The negative here is also telling us that even though normally you would place the DLO of your vertex going this way, in between from your starting point to your ending point in the direction, now that because that answer is negative, we're going in the opposite direction. And we knew this in advance because I told you that's what's going to happen. But if you don't graphically draw out what your problem is beforehand and you don't predict what the slope is going to look like, you might not necessarily know that you're going more north-south than you are east-west. So this would be another major indication of that being true. So we're going 71, I'll write it down here, DLOV is equal to negative 71.4 degrees. We're going to write that in degrees and minutes. So the negative we can drop because we just know that means directionality, and we can work that out on our own now. Do times -1 minus 71 times 60. So the minutes are 24.8 minutes. So we're going in the opposite direction from where our track will be going. So instead of going west like we have been, we're going to go east. So we're going to apply this to the east of our departing longitude. So now we got to write that here. So 155 degrees, 0, is that 3? I think it's 3. Yeah, 03.4. 03.4 minutes west. And then we go 71 degrees, 24.8 8 minutes to the east of that point. So now we do 3.4 minus this plus 60 gets us 38.6 minutes, still in the west. We do 154 minus 71 gets us 83. Okay, so our vertex has a longitude of 83 degrees, 38.6 minutes west, and a latitude of 75, 43.2. So in this type of problem, this equation works exactly the same. You're just plugging in your L1 and you're plugging in your CA. Remember that your CA was adjusted from the way it normally is in the previous video because our slope is so steep. But that works essentially the same, and it gives you a number. Because we're so north-south, that number is higher than it will normally be. Then for the next equation, you plug things in the same way. Because we're so north-south, we get a negative number, meaning that we're going in the opposite direction from what our track is going to be. And so we apply our DLOV in the opposite direction, giving us this as the longitude of our vertex. So now with this ready, we can now move on to creating the waypoint list.